Hello children, today we are going to discuss about rational numbers, which is chapter 1 for mathematics, right? So first, before we proceed with discussing about maths, rational numbers and all, one thing I want to tell you that I want to go really slow. Okay, people who are not able to understand mathematics or who are little kind of hate mathematics, so for them I will make it really simple. Okay, any point of time you have a question, feel free to post a question and I will get back to you. Okay, so with that thought in mind, let's get started. So when we are discussing about rational numbers, let's first talk about numbers. Forget about rational numbers. Let's discuss about numbers and then slowly we'll understand what is a rational number. Okay. So now if we look at numbers, first when as kid we started learning like in class 1, class 2 or during UKG, LKG time, that point of time when we tell numbers, what we normally start counting? We start counting 1, 2, 3, 4, 5 and so on, right? This is how we start counting, right? We do not bother about 0, minus, all these things we don't bother about. We just simple count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So these numbers are called natural numbers. Okay, got it? Natural numbers because these are naturally the numbers that we count. Okay, then when we grow up a little, people starts introduce us to 0, right? So that means 0, we start with 0, then 1, 2, 3, 4, 5, so on, right? And these numbers are called actually whole number. So whole numbers are kind of, you can say whole numbers is equal to 0 and natural numbers, right? Simple, right? Okay. And then we are moving to another type of number, which is negative numbers, right? So all the numbers whatever we are writing till now are always the positive numbers, right? 1, 2, 3, 4, 5, irrespective of the way we count it, these are positive numbers, right? So there are a set of numbers are also negative numbers, right? Like -1, -2, -3, -4 and so on, right? So here you have 0 also, and then if we write 1, 2, 3, 4, 5, so these numbers are called integers. Okay, so integers are what? Integers are basically negative numbers, 0 and positive numbers. So that means whole number, here from here if I look at, this is what? This is whole numbers, right? These are whole numbers and this is negative number, right? So we can say negative number and whole number will be equal to all the integers. Why I'm trying to just draw a relationship between them? Because sometimes the questions might be coming like all whole numbers are natural numbers, true or false? All whole numbers, if you look at here, all whole numbers, so in all whole numbers we include 0 also. So is 0 a natural number? No, right? So all whole numbers are natural numbers, but all natural numbers are whole numbers, right? Because all natural numbers, whatever you think, that everything comes under whole number, right? That is why I have written whole number is 0 and a natural numbers. That means all natural numbers will come within whole number for sure. Similarly, all whole numbers will come within integer, but all integers won't be whole number, because within integers you get negative numbers also, and whole number doesn't contain the negative numbers. Okay, so these kind of little tricky questions also might come. So that is why I am just giving you the relationship between different kind of numbers. Okay, so till now it is clear, right? So simple, right? We have natural numbers that we count naturally, 1, 2, 3, 4, 5. Take along with natural number, take 0, they are called whole numbers. Along with whole numbers, take negative numbers also, and you get integers, right? So till now we have not talked about what is a rational number. Okay, beyond this, do you remember any kind of number? Do you think of any other kind of number that you have read till now? Yes, you guessed it correct. The other types of number that we have are something like this, right? 2 upon 3, or 2 divided by 3, or 2 by 3, whatever you call it. These are called fractions. Correct? You guys already know it, right? These are called fractions. So these fractions are actually our rational numbers. Okay? So any number, how do I say what is a rational number? So any number that can be written in the form of p divided by q, where q is not equal to 0, is called a rational number. I will come to this point. Why q not equal to 0? What happens if q equal to 0? I'll come to that point. Okay, let's understand this. Any number, if any number you can write in the form of p by q, or p upon q, or p divided by q, where q is not equal to 0, then we can say these are all these are all rational numbers. Okay, so can we take more examples? 3 by 6, 2 by 3, 1 by 2, 3 by 9, 18 by 21. All these are rational numbers, right? Because this can be represented in p by q form. Okay, so now the question will be, we spoke about natural numbers, and all natural numbers come within whole number. Whole number comes within the integers, right? All these things we spoke about. So are there any relation between these fractions and other kind of numbers that we discussed? At a first look, it looks like no, there is no relation, because these are anyway fractions. Those are something one numbers we write, right? So there is no relation between them. But actually there is relation, because let's write the natural numbers. Okay, natural numbers that we count naturally. Let's say 1, 2, 3, 4, 5, 6. These are all natural numbers. Are these are rational numbers also? Yes. Why? Because 1 I can write as 1 by 1, 2 I can write as 2 by 1, 3 I can write as 3 by 1, 4 I can write as 4 by 1. So are not these are represented in the form of p over q or p by q, right? So when I write 6 by 1, so here 6 is p and q is 1 and q is not equal to 0. So whatever rule we have written or whatever condition we have written, that is getting satisfied, right? So that is why 6 over 1 or 6 by 1 is also a rational number, right? So that means what you got? Now you got another bigger set of numbers called rational numbers, which actually include anything. Okay, so because here if you look at negative numbers, minus 2 can be written as minus 2 by 1, right? So here p is an integer, q is an integer, and q is not equal to 0. So this is also called a rational number. So any number or any integers till now we know is actually all our rational numbers also, and beyond that also we have fractions, right? Basically let's say 1 and 2, we are writing these are natural numbers, right? We didn't know that anything there in between or not, right? I mean to say, I'm referring to the last slide that we discussed. But in between 1 and 2, I can write 1 divided by 2, right? Half comes in between 1 and 2, right? This is also a rational number. So that means what I want to tell you is rational numbers include natural numbers also, 0 also, negative numbers also, positive numbers also, and that means it includes all integers also, right? So that means first we understood about natural numbers, and along with natural number, if I put 0, this becomes whole numbers, right? And along with whole numbers, if I take negative numbers also, this becomes what? This becomes integers, right? So along with integers, if I take all fractions also, what it become? Become rational numbers. Okay, now it is clear what we mean by rational numbers and which kind of number are included as rational numbers, right? So again, I will just kind of a recap. If you can write any number in the form of p by q, where p and q are integers and q is not equal to 0, then we call them as rational numbers. Okay, so why q is not equal to 0? Because this is like a basic thing. Sometimes we don't understand this, or we have not actually looked into it in a detailed way. That's why we don't understand. But I will tell you that why q is not equal to 0. So our normal division method, what happens? I'll say 4 divided by 2. In normal way, what do we do? 4 divided by 2. So 2 2s are 4 and 4 minus 4 is 0. So now I know that 4 by 2 is equal to 0. But if I say 4 divided by 0, that means 4 divided by 0. What number should I multiply with 0 so that the number comes near to 4? What numbers can I multiply? So in that way, you cannot multiply any number with 0 so that you will actually reach to a result, right? That is why 4 divided by 0 is undefined. Okay, undefined means it is not defined or it is not there. We do not know what it is. Okay, looks little kind of curious, right? We do not know what is 4 by 0 or 5 by 0, 8 by 0 in that sense. Yeah, that's correct actually. We don't know what is it. Okay, so that's mathematics for you. Okay, so these concepts are actually very interesting. Once you go higher, like engineering, or you will do some research on mathematics, that point of time you will know what value does it carry in the higher mathematical field. Okay, so this is just to give you some kind of information about why this kind of things still exist and why do you may face it again. Okay, let's come back to our topic. So now what I have told you, I told you about natural numbers, I told about whole numbers, I told you about integers and rational numbers. Okay, so these things we have discussed in very much detail. Now I think this is clear, right? So next what we will go is, we will go to the different properties. Okay, so first property that I want to tell you is closure law. Closure property. Okay, so let's discuss about it. What is closure property? Okay, I have given one picture here, right? You can see friends are talking and having good time, some good fun, right? So closure property is also something like that. Okay, what do you mean? Means what I'm saying, what is closure property? Something like that. Closure property means, do all the numbers what I'm talking about or going to talk about, do they form a closed group? Do they form a friends group? Or once they get added or multiplied or divided, they become some other numbers? Okay, so if they fall under similar group, we tell them that they are closed. Okay, if they fall under a different kind of groups, we say that they are not closed. Okay, things looks to be little confusing, I know, but let's take examples. Examples are like the best thing that you can take to understand a concept. Okay, so now let's say first we will take natural numbers. Okay, so now what are natural numbers? Natural numbers are simple, starting from 1, right? 1 2 3 4 5 6 7 and so on, right? All positive numbers basically are natural numbers, right? Now let's take the addition operation. Okay, so when you add 1 plus 2, what you get? 3, right? So 1 is a whole number, 2 is a whole number, you get 3 is also a whole number, right? Similarly, let's say I take bigger numbers, 10 plus 15. What it becomes? 10 plus 15 is equal to 25. 10 is a whole number, 15 is a whole number, the result 25 is also a whole number. So that means, I told you, right, these are like closed groups. That means whatever number you take, if you add them, it will fall under a similar kind of number, that is natural number. That means two natural number if you add, you will get another natural number only. You will not get something out of natural numbers. Okay, so that's why we say natural numbers are closed under addition. Okay, the terminologies or the sentence might look little confusing. Natural numbers are closed under addition. That means for addition, natural numbers always give you another natural number. Okay, you add any natural numbers, they will give you natural number only, they will not give you any numbers outside it. Okay, but let's talk about subtraction. Now the concept is clear, right? Subtraction, if you do, I will do 2 minus 1 is equal to 1. I will do 15 minus 10 is equal to 5, right? Natural number minus natural number is a natural number. Natural number minus natural number is a natural number, right? But when I do 10 minus 15, what happens? 10 minus 15, it is minus 5, right? Is minus 5 a natural number? No, minus 5 is not a natural number. Minus 5 is a negative number. Negative number doesn't come under natural numbers. They will come under integers, fine, but they will not come under natural numbers. Okay, so that means here we have to say again that natural numbers are not closed under subtraction. Got it? Why natural numbers are not closed under subtraction? Because there are cases where when you subtract two natural numbers, it can become a number which is out of natural numbers, right? This is the case, right? So you may ask that, sir, you are telling that there are some numbers that also fall under natural number case, right? That means 2 minus 1 is equal to 1, 15 minus 10 is equal to 5. So that means here two natural numbers I am subtracting and getting another natural number, right? Yes, that's correct. But there are also many cases where you subtract a bigger number from a smaller number, okay, and you will get a negative number, right? In mathematics, always remember that if one rule is not satisfied for even one case, that rule is not applicable at all. Okay, here let's say there will be 10,000 cases where this is true, and that is only a single case when this is not true. So this rule is not actually true for subtraction. Okay, that is how mathematics work. If it is true means it is always true. If it is false means there are cases when there are failures. Now we can say for addition and subtraction, we know that natural numbers are closed under addition, natural numbers are not closed under subtraction. That means when you do addition, you add two natural numbers, you get another natural number, any case. But subtraction, there are cases you will get natural numbers, and there are also cases where you will not get natural numbers. Okay, so this is clear. So we will go for now other two operations, which are multiplication and division, right? Let's look at them also. Now for natural numbers, let's do multiplication. So 2 multiplied by 3 is 6. 100 multiplied by 2 is 200. Can you give any number when we multiply by another natural number, we do not get a natural number? No, right? Any natural number you multiply with another natural number, you will get a natural number only. So that means we can say that natural numbers are closed under multiplication. Okay. If we take division, then the answer is very much clear, right? Because if I say 2 divided by 3, what is it? Either I will solve it as a decimal, or it will be 2 divided by 3 is a fraction. So this is a natural number, this is a natural number, but the result is not a natural number. What is this? This is a rational number, right? Because it is represented in P by Q format and Q is not equal to 0, right? So 2 by 3 is a rational number. So division of two natural numbers may not be a natural number. Okay, there are cases it will be a natural number, because let's say I'll say 10 divided by 5. So 10 divided by 5 is equal to 2. So I'll say that, okay, natural number divided by natural number is another natural number. Fine. But there are cases also where natural number divided by natural number is not a natural number. It's a rational number, right? So that means again you can say natural numbers are not closed under division, right? So now you got the concept. Now we have tried the closure property for natural numbers only, right? So we learnt about whole number, right? Means what different kind of numbers we learnt about? Whole number, then the rational numbers and integers also we learnt about, right? So now you try to apply this closure property and figure out, are whole numbers closed under addition? Are whole numbers closed under subtraction? Are whole number closed under multiplication? Are whole numbers closed under division? Similarly, try to find out for integers, try to find out for rational numbers. Okay, this is an exercise. Try this out. If you cannot do it, you are stuck somewhere, for sure I am going to help you. Okay, and I am going to solve this also. But why I am telling you that you should do it yourself? Because if you do not do it yourself and you always rely on the ready-made solution, I am 100% sure that when you face an exam, you will not be able to think. Okay, because mathematics is all about thinking. When a question comes and solution is there in front of you, like I have writing the solution, you say that yeah, this is correct. But when you think yourself the problem only, there is no solution written in your front, then things becomes difficult. I have faced it. I have almost kind of failed in maths and then zoomed to the top of the maths. Okay, the only thing that I did while just keeping some fail mark and then moving to the top of the mark in the maths is practice. Okay, so do a regular practice for mathematics. Get stuck at a point that's obvious, that is natural, and it is very good, because when you are stuck at a point, that means your mind has thought over it and you are stuck at a point. That is good, that is well and fine. Okay, because I am here to help you out and I will tell you that where you are stuck, is it a what exactly you thought wrong, so that you don't repeat it again. Okay, so I hope till now things are clear. Okay, so we discussed about different kind of numbers: natural numbers, whole numbers, integers, rational numbers. We took different examples and then we saw the closure property only for the whole numbers. So your exercise is to figure out the closure property for whole numbers, for integers and for rational numbers. Okay, so do this exercise. Let's see in the next class we will discuss this and we will understand few more concepts also. As I told you in beginning, I will go slow, I will repeat things, but I will tell you things in very detail. I want you should understand it fundamentally. Okay, if you are fundamentally strong, you can actually do any kinds of mathematics. If you are fundamentally weak, then after some time mathematics seems to be tough, mathematics seems to be something which is not doable, you will not feel interested, your marks will go down, all these things will happen. Okay, so let's understand mathematics fundamentally, and speed is there anyway. Once you understand things better, you can acquire speed. Okay, but let's first start it slow, understand it fundamentally, then you fastest speed you can achieve, you can go with that. Okay, with that thought in mind, try to do this exercise and let's meet in the next lecture. Thank you.